Hey guys, lower my chair. This is the endocrine system, and I'm going to move through pretty quick so that I can make sure that you are caught up. Okay. All right. The endocrine system produces and secretes hormones into the bloodstream. Okay. Chemical signals that regulate other organs in the body. That's the definition for hormones. Endocrine glands secrete products into the bloodstream. Blood carries those hormones through the blood to the target cells that will react when the hormones are detected. So protein hormones then are going to interact with the receptor on the membrane of the cell, the target cell. Something called CAMP or cyclic AMP sets the metabolic machinery in motion and is a secondary messenger. Okay. Steroid hormones. Hormones are hydrophobic. And able to enter the cell in the same manner that lipids do across the cell membrane. So steroid hormones are going to bind to a receptor once they get in, and that receptor is usually in the nucleus to promote whatever change is needed by the hormone. Let's start with the hypothalamus. So the hypothalamus is considered the kind of master regulator when it comes to homeostasis, or all of the life functions that happen in our bodies that keep us stable, whether it's, temperature and metabolism and things like that. So the hypothalamus is going to link the nervous system with the endocrine system. Okay. Look at the pituitary gland, pea-sized. It's little tiny endocrine gland. It's controlled by the hypothalamus, and it's divided into an anterior and a posterior region. And each of those regions have their own function. So the posterior pituitary secretes an antidiuretic hormone, or ADH. This regulates the water-salt balance in the body, and is something that's going to end up working with the kidneys. Okay. So again, the hypothalamus is going to control this, and specifically neurons that can report back to the hypothalamus are going to detect the concentration of water and salt in the blood. Okay, so the ADH hormone is released when the concentration of solutes in the blood is too high. Okay, so antidiuretic, this means to conserve water, right? So when the solutes are too high, that means we need our solvent, which is water, to balance that ratio out. And so the ADH is going to say, hey, conserve water. We need to keep water in here. Again, that is going to work with the kidney because in the part where the kidney, the nephron, where the kidney is recycling and water is being reabsorbed, it kind of tells the kidneys, leave as much water in the system as you can. And that's when you get like the super dark urine and stuff like that that we talked about. So what effect does it have? It reabsorbs water. Then there's something called oxytocin. And oxytocin is regulated by one of the feedback loops. In this case, it's a positive feedback loop. It's hard to see, positive feedback. So in other words, the body is triggered by the oxytocin, and then the reaction of the body to the oxytocin makes it keep secreting the oxytocin, okay? So oxytocin is a hormone that's released during birth, because when the baby's head presses down on the cervix, preparing for birth itself, it stimulates the release of this hormone called oxytocin. And oxytocin causes contractions, uterine contractions, and those contractions are going to thin out the cervix so that it thins to the point that the baby can pass through it. And that's why it's a positive feedback, because as oxytocin is released, it causes the cervix to thin, baby's head keeps pressing on the cervix because of it as it moves down, and more oxytocin is released. Okay, how could you induce labor? There is a fake oxytocin or synthetic oxytocin called Pitocin. Okay, and it simulates the natural effects of oxytocin. I've heard that labor that's induced with Pitocin can be a lot more intense, like the contractions can be more painful, mostly just because the body isn't producing good grief, sorry guys, the body isn't producing that hormone naturally. It's being forced into producing it, and so the body hasn't really hit the stage of readiness to allow those contractions to happen. But at the same time, Pitocin is it's this fantastic thing that we have, because some women's bodies don't really naturally trigger into labor very strongly, and that in the past has caused death for babies and moms. So that's an awesome thing. All right, so we talked a little bit about oxytocin. Again, it targets the uterus, causes contractions. It also targets the mammary glands and the breasts to cause something called letdown. Basically, it allows for milk production from the mammary tissues. When the oxytocin is present, it triggers that milk production, which is also a positive feedback loop. Yeah, when oxytocin isn't present, then that milk will dry up eventually. So these are secreted by the hypothalamus. I'm sorry, they are made in the hypothalamus, secreted through the posterior pituitary. Okay. Right. Now we've got our anterior pituitary, again, controlled by the hypothalamus through something called the portal system. Okay. So portal system is, we've got a system of blood vessels that are going to deliver inhibitory or stimulatory hormones to the pituitary. So notice that it can either inhibit a body response or it can stimulate a body response. Hormones can do both things, okay? So we have something called TSH, or thyroid stimulating hormone, which does what it sounds like. It stimulates the anterior pituitary to release this thyroid stimulating hormone, which then causes the thyroid to release its own set of hormones to regulate thyroid function. Okay, so you've got a thyroid stimulating hormone, but you also have a thyroid inhibiting hormone. Okay, which does the complete opposite. It keeps the pituitary from sending the signal that the thyroid needs to ramp up its production. So it inhibits the release of thyroid stimulating hormone. So you've got the thyroid stimulating hormone, which will cause the thyroid to increase its own hormones. But then on the opposite end, you have the thyroid inhibiting hormone, which works with the hypothalamus to keep the pituitary from releasing the hormone. That didn't make sense the way I said it. It made sense in my head, but the way it came out of my mouth, I think, did not. Basically, it prevents the release of TSH. How's that? So it's, yeah, it prevents the release. There you go. Again, what I was trying to say made sense in my head, but I think I'm gonna leave it at that because I don't think I'm making it better for you. All right, so what is the thyroid? Thyroid, it's kind of showing you a picture. If you put your hand about here, you can't really even see where I'm doing it, on your throat, it's actually closer down here. And you swallow, sometimes if your thyroid's enlarged, you can actually feel it against your fingers. It's this butterfly-shaped gland across. And it is super important. There's a lot of really common thyroid disorders, hyperthyroidism, too much thyroid hormone, hypothyroidism, which is the opposite, it's too low. The thyroid regulates a lot of different functions in the body, a lot of basic homeostasis-like activities. It regulates, sleep cycles, weight, metabolism, temperature, all kinds of stuff. So thyroid issues can show up in a variety of symptoms or as a variety of symptoms. Again, it's located below the larynx. Larynx releases thyroxine when stimulated by thyroid releasing hormone. Okay, so what does thyroxine do? Well, I kind of went over some of them, but we'll fill it out. Maintains your basal metabolic rate. It increases protein production. It increases glucose levels when needed. It increases lipid synthesis and the heart rate. And again, it maintains mood and sleep. So again, if any of these things are disrupted, they may be an indication that there are thyroid issues happening. Thyroxine is regulated by negative feedback, so the opposite of our oxytocin. Thyroxine release will stop the release of more thyroxine by inhibiting the release of thyroid stimulating hormone and the thyroid release hormone. So when the thyroxine gets released, the presence of the thyroxine in the system is what keeps more of it from being produced. Basically, that's how it works. I can spell release TSH, and I guess I'll write this one out because I haven't put it before. Thyroid releasing hormone. So if you ever have blood work done for your thyroid, they usually do a couple of different, they'll look for a couple of different things in your blood. There's TSH, so looking for the level of TSH in your blood. They look for T3, they look for T4, they look for, shoot, it's called free. I can't think of what the other one's called. There's a few things that they look for. And each one of those kind of gives some information about what's happening, not just with the thyroid, but with the hormones that are being released to control the thyroid. From there, they can decide how they're going to treat. There's a common thyroid medication called levothyroxine. It's synthetic thyroxine. Does the job that needs to be done, but that the body isn't doing. Okay. All right. So symptoms of hypothyroidism. Hypothyroidism, again, this is going to be lower. Okay, the thyroid function is lower. Okay, so you'd expect things like, you know, since it's going to affect body metabolism, you'd expect different tolerances to heat and cold. You could expect weight gain. You could expect fatigue, a lower heart rate, sometimes mood symptoms like depression or what's it called? You know, being patient and snappy, stuff like that. All of that because, as you can see from the last page, thyroxine should be increasing heart rate, increasing, what are some of the other things it mentioned that I said? Oh, glucose, increasing the glucose levels available in the blood. And all of those things are going to affect your energy, right? So when it's not functioning properly, you have the opposite of all of that. I guess I'll write it out. Where is it? Sorry. Low tolerance to colder temps because the body would already be a little colder than normal anyway. Not everybody has every single one of these symptoms, but they're pretty common. Fatigue, have weight gain or just an inability to lose weight. What else? Lower heart rate. Okay, stuff like that. Oh, I forgot our mood disorder stuff, so depression, even anxiety, things like that. All right, hyperthyroidism, obviously this is going to be the opposite, and so we're going to have the opposite of these things. Although you can still have the mood imbalance issues, a little less common with the depression, but you can have anxiety, restlessness. Instead of being tired, you have an inability to sleep, so insomnia. Instead of weight gain, you have usually a rather rapid weight loss, hard time holding on to weight. Heart rate is going to increase. You've got a rapid heartbeat or heart rate. What else? Am I missing anything? Usually sensitivity to heat instead of sensitivity to cold. And again, that's because your body's running warmer than normal. That's just basically because all the chemical reactions in our body, that's metabolism. And thyroid issues affect metabolism either by slowing it down, which means you're not generating as much heat because you're not having as many reactions taking place, or on the other end, speeding it up, which means your body's going to be warmer because you're doing a lot more reactions in a small amount of time. That's kind of how it messes with body temperature. Then we have something lovely called goiter, which is, you can see here. Goiter is simply an enlarged thyroid. It gets bigger and bigger in an attempt to produce the right amount of hormone that the body needs. And because it's not, it enlarges. Back in the day, there was a time where goiter was considered a thing of beauty. Some of the queens in Europe and England that had goiter, it was considered beautiful. I didn't realize, of course, what it was. But the most common issue that causes goiter is a simple lack of iodine. Iodine is a trace element, meaning for us it's a trace element, meaning we don't need a whole lot of it in our bodies, but a small amount is essential. And because iodine is contained naturally in not a massive, array of foods, a lot of people just weren't getting it. In fact, it can still be something in our diet today that we might not naturally, how would I say it, might not naturally be drawn toward those foods. So to prevent that, I can think to prevent that, they added iodine to table salt, which is why if you buy table salt, it usually says iodized table salt. So they put in that trace element with the salt because we consume that, even if we're not adding salt to our food, most of the foods we eat contain some level of sodium, and most of that has been iodized. So that's where we get it from today. But again, without iodine, the thyroid isn't going to be making any thyroxine, okay? Because of that, we have thyroid stimulating hormone and thyroid releasing hormone constantly being made, okay? Because the signal is being sent. You're not producing it, you're not producing it, you're not producing it. So the thyroid's like, geez, I'm trying, and it gets bigger and bigger in its attempt to push out more thyroxine. So thyroid gets larger in response. Okay. Look at the pancreas. So the pancreas is interesting because it is both an endocrine and an exocrine gland. We'll look a little bit about what that means here in just a second. There's something called pancreatic islets, and these are the cells that secrete hormones in the pancreas. So this is a little slide of endocrine tissue, and it's showing the islet of Langerhans, or these little secreting cells. Okay. We know that the pancreas is essential for the natural regulation of glucose levels in the blood. Okay. So we have something called alpha cells. And alpha cells secrete glucagon. Okay. The glucagon is going to target cells in the liver. And when that happens, the liver is going to break down of glycogen, which is sugar storage. So when there's too much sugar in the body, it gets sent to the liver, and the liver converts it from glucose to a longer term storage called glycogen. Okay. When blood sugar drops naturally in your body, glucagon is going to tell the liver to start converting that glycogen back into glucose and releasing it into the bloodstream to regulate the blood sugar. Okay. So it's going to signal conversion of glycogen to to glucose. Okay. All right. And then on the other side, we have beta cells. And beta cells secrete insulin. Insulin is going to target both the liver and the muscle cells, and this targets the uptake of sugar. Or I'm sorry, it signals the uptake of sugar. So in the muscles, we have a lot of cells that contain a ton of mitochondria. If you remember, this is where ATP is generated. And if you remember cellular respiration, ATP, one of the easiest ways to harvest ATP is through breaking down glucose. So you eat something, that glucose is taken up by the muscles and converted to energy. And then again, the excess is sent to the liver where it's converted into glycogen for longer term sugar storage, okay? So when you ingest something that's breaks down into a sugar, and it doesn't just mean like something sweet, it means breads, pastas, potatoes, things like that, then those beta cells are stimulated to secrete insulin so that all of that glucose that rushes in can actually be picked up and used, either used by the muscles or stored by the liver. Okay? Okay, last page. Diabetes mellitus. This is where we have an inability to maintain glucose homeostasis, or in other words, being able to regulate the glucose levels in the blood. One of the body's ways of attempting to cope with this is to add, how to put this? One of the body's ways of trying to cope is to excrete the extra glucose, okay? So in trying to get rid of that extra glucose, more water gets pulled into the kidneys. And then it's kind of a hypertonic type of situation that pulls in more water because the water is there to help to excrete the glucose. And this has a couple of issues. Okay. So the fact that this happens is one of the reasons that undiagnosed diabetes, or people that have it, often experience excessive thirst. And now, having watched it firsthand, it's excessive thirst, and usually excessive and very frequent urination because so much water is being pulled in to try to get rid of all that extra glucose that you have to go to the bathroom a lot. In addition, diabetes that's unchecked leads to fatigue, which is an understatement. It's like sleeping all the time. Intense hunger, usually because the body is trying to say that it needs more food to be broken down to create energy, okay? So even when you're eating food, since the insulin isn't being released to use, especially the glucose that was in those foods, your body's always saying, I'm hungry, I'm hungry, I'm hungry, I need energy, hurry. High blood pressure, this has to do with water intake. And then long-term, damage to kidneys, because again, the kidneys are attempting to filter out extremely high levels of glucose. It causes damage to the eyes, and a lot of that has to do with the little blood vessels in the eyes. It can cause nerve destruction, heart attacks, strokes. Other things that aren't listed here, it can make it extremely difficult for wounds to heal. It's because of a blood pressure and usually damage to smaller blood vessels. It doesn't allow for an increased blood flow to the site of the wound. It takes a long time to be able to heal, an increased risk of infection, a harder time healing from infection. The list is on and on because of how it starts to affect everything in the body. And of course, once it hits the kidneys, then it's a nightmare because, as I talked about, kidneys and heart don't play well together. Blood pressure medication often negatively affects kidneys, and kidney medication can have an adverse effect on blood pressure, and it's just this constant balancing act of medications. Type 1 diabetes is often called juvenile diabetes because it tends to strike children and young adults, okay? And again, this is caused by insufficient insulin, produced by those beta cells. Okay, so, well, I'll get into that in a second. Type 1 diabetes is considered an autoimmune disorder that has targeted and destroyed those little pancreatic islets, the islets of Langerhans, that have been secreting insulin, okay? It's believed that a virus of some sort started it. To say that it was caused by a virus, it's more like the virus's presence triggered it, because this is autoimmune, and autoimmune disorders do have rather strong genetic links. It's usually that there was in the genes, the genes in the body were already present for an autoimmune disorder to occur. And in autoimmune disorders, usually in multiple generations, it doesn't show up the same way. So, somebody can have chronic fatigue, a mom can have chronic fatigue, and the daughter can have rheumatoid arthritis. And then the granddaughter can have, type 1 diabetes. And then the great-granddaughter can have lupus. I mean, it just shows up differently in each generation. And that's generally because of some sort of outside stimulus, something outside the body that causes the gene with the autoimmune mutation or issue. It causes the gene to become active. And then, you have the effects that occur on the body, okay? So they think that it's some sort of a virus that just was kind of the last straw, if you will, that sent the body spiraling into creating or turning on this gene for this autoimmune disorder. And in this case, it's decided to take out the pancreas, or specifically the beta cells, insulin secreting cells in the pancreas. Other types of autoimmune disorders like celiac disease can wreak havoc in the digestive system. If gluten is there, gluten's the trigger. And then you've got, shoot, I had 2 or 3 things I was going to list. Oh, Hashimoto's disease. It's not just hypothyroidism, it's an autoimmune issue with the thyroid triggered by gluten. There's all kinds of different ways that the body can respond to a trigger that just happens to make an autoimmune disease active. So if type 1 diabetes is left untreated, it leads to something called ketoacidosis, which basically is where fat metabolism leads to an increase in something called ketones in the blood. And these can be monitored in the urine. So the body, as I've said, likes to use glucose for its main source of energy. It's quick, the body's really good at breaking it down efficiently for cellular respiration. There are other molecules, which I touched on briefly during the cellular respiration part. There are other molecules that can be used, but it's slower, provides less energy usually, and then has a negative buildup of other things in the body. So even though somebody with diabetes type 1 can have like all the glucose, right? You need, a pasta dinner, all the glucose is there. The problem is there's no insulin, which means the glucose isn't being picked up to be used for energy. So the glucose that's sitting there becomes a toxin to the body. In the meantime, the body is digesting fats. Those fats are generally coming from the body tissues themselves. So you can have extreme and very fast weight loss as the body is breaking down muscle and tissue in an attempt to find some kind of energy. And I don't mean energy for like walking around even, I just mean energy like making sure your heart's still beating. And so the result of this high fat metabolism is something called ketones. And so you can look in the blood and also take a sample of urine to see if ketones are present. And if they are, it means the body has flipped over into needing to start digesting fats in an attempt to provide energy for life functions. Okay. This is treated with insulin. Okay. You have insulin in the system. Now all that glucose that's just sitting there can be picked up and it can be used instead, and the body will leave all of the fat stores alone. And once it's gone through the fat stores, like I said, it'll go through the muscle. And so the body will leave all that alone as long as insulin is present. Okay. Type 2 diabetes. This is adult onset. Type 2 diabetes is insufficient response from the insulin receptors, okay? So the insulin can be produced, but the receptors aren't acting very strongly to pick that glucose up anyway. And so this is also called insulin resistance. Insulin resistance is associated with obesity and also treated with insulin. It can have something to do with causing the body to want to hang on to converted glucose levels. So in type 2 diabetes, with the fact that the insulin receptors aren't doing their job, it reduces the amount of transporters that are available to move that glucose around. Okay. All right. That's actually the end of this. And symptoms, by the way, of type 2 diabetes are very much the same as are the dangers to type 1 diabetes. In adults, you can often have other signs and symptoms that it's building, that it's coming on, and a blood test will show if that's the case. With the type 1, it's generally something that kind of comes out of the blue. It seemed fine one week, and then the next week we have really pronounced symptoms of ketoacidosis and really high blood sugar. So adult 2 can sneak up, but if you normally have enough symptoms that you've been visiting a doctor anyway, and so it's been caught, if that makes sense. Type 1 with the kids, not so much. All right, you guys, that is the end of this lecture. I'll see you soon.